these two are common data questions, and the data for the two questions is given. Consider the following ripple counter shown in figure. The output of the two input OR gate is used to clear the JK flip-flops. Here a ripple counter is given. Ripple counter means output of first flip-flop would be supplied as clock to the second flip-flop, and output of the second flip-flop is here supplied as clock to the third flip-flop, and here flip-flops are JK flip-flops, and here the clock is negative edge triggered. Negative edge triggered means it will here the clock is negative edge triggered, and that means flip-flop will change its state when clock input will change from 1 to 0. When clock transition state changes from 1 to 0, then flip-flop will change its state. So here let us take initial state, and here OR gate is used to clear the flip-flops. And here it will clear the flip-flops whenever the output of OR gate is 0. That means B bar and C bar should be output of OR gate is 0 when its both inputs are 0. That means here B bar and C bar should be 1 in order to activate this. When this activates, it will be the counter will be reset. So now let us take starting state as 0 0 0. So here as J and K are connected to 1, here output next state would be complement of its previous state. So this 0 will change to 1, and here this will be supplied as input to the clock of the second flip-flop. So here 1 to 0 is there. So 1 to 0 is, as it is negative edge triggered, this will not change its state. So this will remain as same, and from 0 to 1 also it will not change the state. So and here 1 will change to 0. So now this clock will be transferring from 1 to 0. As it is negative edge triggered, the output of the second flip-flop will be changed. That means it is complemented as J and K are connected to 1. So 0 will become 1, and from 0 to 1 it will not change the state of third flip-flop. So here it will be 0. Now this 0 will become 1, as it is clock transfer is from 0 to 1. It will not change its state. So 1 will become 1 only. So here 1 to 1 also no change. So this will be 0. Now it will be 0, and from 1 to 0 it will second flip-flop will change its state. So 1 will become 0. So 1 to 0 also it will become here 1 will become 0 will become 1. Third flip-flop will change its state from 0 to 1. The next state is complement of its previous state. Why? Because it is JK flip-flop and both J and K are connected to 1. So this is the state. Now this 0 will become 1. It will change the output will be the next state will be complement of input, complement of previous state. So 0 will become 1, next state will be 1, and this will be transferred to the clock of the next second flip-flop. So as it is negative edge triggered, it will not change its state when the transition is from 0 to 1. So this will become 0 only. Here also it will not change. This will be 1. Now this will become next state of A would be 0. Now that is flip-flop A is 0. First flip-flop is 0. Now as it is 1 1 changing transition from 1 to 0, it second flip-flop will for the next state would be complement of previous state, so it will become 1, and it is from 0 to 1, so it will not, third flip-flop will not change the state, so it will become 1 only. As that means here B bar and C bar are 1 1 1, so B and C would be 0 0. Then the output of this OR gate is 0. Now as it is 0, this flip-flop will be reset. That means it will go to the starting state. So here the counter, the modulus of the counter is 1 2 3 4 5 and 6, which is option B. And the next question and the second question for the same data is, what is the modulus of the counter if instead of OR gate 2 input AND gate is used to clear the JK flip-flops. Options are, first option A 2, option B 4, option C 6, option D 8. So here just in this question, just this OR gate is replaced with AND gate. So output of AND gate would be 0 when both are, when any of the inputs are 0. So here let us take starting state as 0 0 0. Now this will become 1, and as it is negative edge trigger, it will not change. This would be 0 and this would be 0, and this will become 0. As it is negative edge trigger, it will change, the second flip-flop will change its state, so this will become 1, and it will not change. So this would be same, this would be 1. So it is from, so here if we see here B is 1 and C is 0. That means B bar is 0 and C bar is 1. That means this AND gate, here it will be AND gate in the next question. So this output will be 0. Whenever it is 0, this counter will be reset. That means from here it will go to initial state. That means the modulus of the counter would be 1 2, which is option A.